session first. What we have done, guys, if you guys remember that we have covered the basically the BGP route reflector. We have seen the concept of the how we can prevent the loop in the eBGP and iBGP. So in the eBGP, we have basically AS path information, right? That's gonna help to prevent the loop. And in the iBGP protocol, we have a split horizon rule, right? So this split horizon rule helps to prevent the loop. But there's a problem, right? Because if the split horizon rule is enabled, then what happened? Understand the concept. So we have router number one, we have router number two over there, and we have router three, right? So normally what happened in the after if the iBGP is running between the router one, router two, router three. So to understand 1, 2, 3 is number. And here we have this is 12.1 and this is 12.2, the IP address 23.2 and 23.3, right? So if you have a route 1.0.0.0/8 behind the router number one, so normally what happened, router one can save this information to router number two through the update packet, right? So router two is going to have this information in the BGP table as a star will be a valid symbol and the greater than is the best one. You have 1.0.0.0.0/12.1, right? /8 route. Now R2 cannot save this information to the R3, right? Because of the split Trojan rule behavior. This is the issues, right? No, not a issues. It's a good thing, right? Because it's a loop prevention mechanism. So to avoid this thing, right, what we can do that we can make we have seen the two solutions, right? The full mesh, we have seen that. In a full mesh, basically what happened, each router is going to make a mesh with every router. And then another solution that we have is called as a route reflector, right? This is another solution. So two solution we have seen that. So in the first solution, the full mesh, if you guys remember that, it is not scalable, right? Second thing, higher number of lines of configuration will be increased, right? Lines of configuration will increase. And the third thing is that what's the problem is that you have a multiple TCP session. So that's a biggest disadvantage, right? And that's gonna degrade the router performance. It degrade the router. It doesn't mean that full mesh is a bad thing, right? In some scenario, if you when you go to the higher level, right, you will understand the full mesh is good thing as well in some scenario. And but now as per the CCNP label, what you need to understand what is BGP, okay? So yeah, it's a bad thing about the full mesh, right? Data performance is gonna degraded. That's why we came with the solutions called the RR. We can call it the router reflector. So we have about three components in the router reflector. We have a client, one we have a server, one we have non-client. So basically what happened in that RR, so you will have a one centralized router. Take example, this is my router number two we have, and this is my router number one we have, right? This is router three we have. So in this case, what happened? This is the client router, this is the client router, this is the server router. So the client has an information. Take example, we have a 1.0.0.0/8. R1 is going to share this information to router number two. Router two will have this information in the BGP table. And normally what happened, then router two can reflect this information to the R3, right? 1.0.0/8 information. That's a behavior of the route reflector. So I'm just going to reflect what I'm going to reflect. I'm going to reflect the route. So this is the guy who is behave like a reflector. He will receive the route from the client and just reflect to the another client, right? Only the thing is that what? I'm so sorry. Only the thing is that what? Like in this case, what happened? iBGP does not change the next hop. That's a very important. So if you see the 12.1 and this is the 12.2 and 23.2 and 23.3. So normally what happened? R3 will receive this update 1.0.0/8, have a 12.1 as a next hop, right? So in that case, what happened? This route just will be a valid route, not the best, because I cannot reach the 12.1. So we need to make a reachability between this network and this network, right? Then we can have a best route. So BGP always look for the reachability. If the next hop is not reachable, right? It's a very, very important troubleshoot, right? If the next hop is not reachable, then BGP never marks that route is the best. So if your next hop is reachable, right, from R3, if I able to ping the 12.1, then I can make this guy the best route. So normally what you can do that either you can run the EIGRP routing protocol to advertise this particular link, or either you can do with the what? Either you can do the static route as well. So that's how you can do that. By default, also one more important thing, eBGP does change the next hop. but IBGP does not change the next hop. That's a very, very important statement. So, these things are very important when you go over the interview level. So they will ask you, hey, what is the difference between the IBGP and EBGP, right? So normally what people are saying that IBGP, okay, we can go with the same autonomous system number. EBGP, you can go with the different autonomous system number. Okay, IBGP has a 80 is a 200, EBGP has a 20, right? Then after that, you can also say that, okay, IBGP has a TTL value is a 255, EBGP has by default 1. Apart from this thing, this is the major disadvantage, like a difference, right? So I hope this thing is clear to all of you guys. So we did this part in the last class. So also we have seen the concept of the network statement. So if you have a class pulled out, you can just put the network 1 or 0 or 0 or 0. That's all. You can also advertise like this way as well. If you want network 1 or 0 or 0 or 0 and mask keyword. So both the way you can do that with the help of class pulled out. But if you have a class listed out, right? If you have a class listed out, then what happened for the class listed out, you need to always define the mask information, right? So this is mandatory for the classless. So this is for the class pool. So either you can do this way or either you can do this way. It's up to you. But recommendation is this way always. And this is for the classless, right? I also told you that, right, full mesh and data filter. Apart from this thing, we have another solution that's called as a configuration, right? So this is not in the topic. So normally a part of the CCI, but we'll discuss this thing, configuration. So understand the concept one thing. So your ACE number that I told you, if you remember that, is basically an autonomous system number. You have a large group, right? And this large group has multiple routers over there, router 2, router 3, right? The router 4 we have. To identify this large group, right, routers, we have to put the identifier, and
Hello?
that identifier is called as the
Yeah.
ACE number. Yeah.
Sorry for the interruption.
Yeah.
I just have a doubt. You were mentioning AS number, right?
Yeah. Yeah.
In real-time scenario where it is mentioned, for example, the two cloud are different AS number. While configuring the, BGP, you mentioned AS, right? A remote as AS number, right?
Yeah. Yeah.
In where it is real-time mentioned, is it a virtual? Is it our assumption or?
No, it's not
How?
assumption. It's not assumption. Okay, so normally what happened? So it's
No, you got my question or not?
I got your question. I got your question. So normally it's
Okay.
not a like virtual. That's something. You need to take a AS number from the ISP. It's not a free. So
Okay,
ISP,
they will assign.
they will give you the AS number. It's not a free. You have to pay the money for this one. Like a public IP, right? And
Mm,
private IP, same
mm-mm.
thing. So public IP has like you have to pay the money for the public IP, same thing. AS number is not a free. You have to pay the money. But some AS number are free. That's I'm coming to the point.
Okay, okay.
Okay, so take example. You have one company. That company name is ABC. Okay, I am the service provider right now. I took the AS number from the INA. So INA company, the internet communities, though they are giving the what AS number to the this guy ISPs. It's a long process. Okay, but like I'm just giving you this small behavior. So INA is giving the AS number to the ISP, and what ISP will do that? If you have a requirement, right, of the BGP in your network, then you will ask the ISP, hey, could you please give me the one AS number? Then then ISP will give you the AS number to you. For example, they will give you the AS number 2. What service provider is using the AS number? Maybe the 100. So in that case, what happened? Your AS number 2 will, 1 will be the local AS number and the 100 will be the remote AS number. You understood now?
Yeah. What in case in previous example you used to tell when we connect to two different companies, they are on a different EAS you mentioned, right?
Mhm.
Is it only ISP give the having the EAS number or even companies?
No, AS number is always given the like this one, what we call ISPs. Not
ISPs,
yeah.
okay.
So that's I'm
No,
coming to the
for
current, but
example,
it's still,
purpose you are
companies can also use it. So basically, I'll tell you one thing. So we have a range is called a 65535. That's a 16-bit of AS
Mm,
number we have.
mm,
And
mm.
also we have a 32-bit as well. If you remember that I have explained this part. So in the newer IS
Yes.
version, we have a 32-bit. Older IS version, we have a 16-bit.
Yeah,
16-bit,
12
we
and
have
15
done
you
with the
told.
exhausted. It's like a same IPv4 and IPv6. So we have done with
Okay.
IPv4, right? So that's why IPv6 comes in the picture. That's a main reason, right? So we have done with the 16-bit. That's why the 32-bit comes in the picture now. In this 65535, right? 12655, this is the range we have. In this one, what happened? 64512 to 65534 something. These are the exact 34 or maybe 35 is there, the range. So these are the ranges private. Apart from all this, right? It's a public case number. For example, 1 to 200, 300, 1000 or 64511. These are all as a public ACE number. So these ACE number, company can use it. No need to take a help of the ISP.
Okay.
Okay. But if you're going to use the public ACE number, then you have to pay the money for the ISP. Then you need to take a permission. It's not like any ACE is free in the market. Because remember what I told you that if you remember the eBGP ACE path loop prevention mechanism, right? I explained how the loop prevention is working. So take example, if I'm also going to use take example, this is the one company. The company is ABC and they are using the ACE number 1. Okay. The company XYZ is also using the ACE number 2 right now. Understood this concept? Then you will understand this thing. ACE number 2, right? So tell me one thing. If I'm going to share this update 1.0.0. Will XYZ will accept this route? They will, right? Because they have different ACE number. But take example, what happened if, take example, if the companies are going to use the ACE number itself, not going to take the help from the ISP, then what happened? This guy said, hey, my company's name is JKL, and I'm going to use the ACE number 1 again. Now, what do you think? When the ACE number 2 is going to advertise this route to the JKL company, will ACE number 1 accept this route, the JKL? No, they will discard it. Loop prevention mechanism of eBGP. So that's why ACE number must be unique in the internet, must be unique. Yeah, some companies, for example, if you have a same ABC company in the India and the ABC company also in the United States, take example, then what happened? ABC over there, then they can, if they want to save the money, they can use the same ACE number, right? Now, how they will exchange that out, it's an advanced topic, but they can do that.
Okay. Okay.
Okay. Yeah,
Yeah.
Bhujan had asked the question like, what is the range of the ACE number? So we have it this range. I'll show you that, Bhujan. Don't worry. Okay.
Okay, sir. Thank you.
Great. So I was there, right? So I said that this is the logical group, and to identify this logical group, we need to put the ACE number. Same thing, to identify this logical group, we need to put another ACE number 2 over there. So these are the public ACE number that you have to pay the money. But apart from the public, we have a private range as well. This is the free to use. But again, these private range are locally. So when you're gonna send this private ACE number to the service provider, take example, so one of the company that has took the private ACE number, right? And if this guy is gonna send this private ACE number to the ISP, what ISP will do that? ISP will discard this one. ISP will never share this private ACE number to the another company. Never ever. It will remove it. Manually, you need to do that. Manually, ISP is doing this thing. There's no like a filter and something like that. Manually, there is a command that when you see when you come to the CSAT, then I will explain you. There is a command, something like a remove private ACE number. So by using this command, what happened? Basically, your private ACE will be removed. You need to go under the neighbor and neighbor say the remove private ACE. So the private ACE never travel on the internet side, never ever. It's local to the customer side. It will just share the information to the ISP, just make a connectivity, that's all. ISP will never share this private ACE number to another ISPs or maybe another companies. Okay. Now, what I told you, the configuration, right? So basically, if you understand what configuration is going to do that. So configuration is breaking. Hey, who has asked the question? Firoz, right? You asked the question. You understood, right? The ACE concept. Firoz, are you there? Who has asked the question? ACE? I think so. Huawei and was I don't know.
Yeah, it's me. My internet is quite
Okay.
disconnected. That's why.
You understood, right? ACE concept.
Yeah, I got it. I got
Got
it.
it. Great. So configuration, understand the concept. Configuration, right? Just a simple understanding because it will be very complicated for you right now to explain the higher level things. Okay, I'm making a very simple. Configuration is just an alternative right now at the CCNP level. Okay, because the things that I'm going to explain to you at the configuration is very high because normally I don't teach the configuration in the CCNP, but understand the concept. What configuration is doing that? Configuration is just an alternative of RR. Simple. Okay, what configuration is gonna do that? It's just gonna break a public ACE number into private ACE number. Okay, you can also break. Okay, this statement can be conflict as well, because you can also break in the public ACE number. You will see somewhere written over there. You can also break in the public ACE number, but never ever recommendation to do that, because if I'm gonna break the public ACE number into the public ACE number, then what happened? I need to take a multiple public ACE number. And if I'm going to take a multiple public ACE number, I have to pay the money for the multiple public ACE number. So that's why we are converting into the public to the private over there. How? Understand? So let me open my topology over there and I'll explain you. It's a little complicated than RR, but I'm telling you, it's a important one. If I talk about the exam perspective, you know, even in the CCI lab exam, I'm talking about not the CCNP, forget the CCNP, CCI lab exam, I haven't seen the configuration anywhere. So always you will see the RR. RR, you can see the full mesh as well, but in the production, you will see the configuration as well. See, at the NP level, for the BGP, you need to understand what is BGP. That's all. Even at the NP level, nobody will ask you the question from the BGP. Yeah, when you have a good experience, like a 5 to 6 years experience, and if you don't have a good knowledge in the BGP, then they will kick out simply. So you need to know most thing in the BGP protocol at the level of the 5 years of experience, right? Very detailed level. Okay, but if you don't have, then the problem comes in. But at the fresher level, at the NANP level, right? Fresher level, BGP, you need to understand basic things, fine. But as for the I level, you need to go in the more and more depth, right? Because RR itself, like normally, so in the RI, if I talk about, so in the normally in the CCI classes, I took the RR class almost 3 to 4 hours for the RR only, 4 hours minimum. Right. Okay, let's go to the configuration. So if you see right now, what we have over there, we have a ACE number 1, 2, 3, right? That's my public ACE number. Okay. What I did, if you see that, I just break the public ACE number, right? I just break the public ACE number into the private ACE number. How? If you see that all these routers are part, router 1, router 2, router 3, router 4, router 5 is the part of what? They all are the part of the public ACE number 1 to 3 in the same ISP. So I can say that ISP number 1, right? But what I did, because I'm not going to use the router reflector over there, what I can do that, I'm going to use the configuration. So what configuration is going to do that? It's going to break the public ACE number into the private ACE number 64512, 64513, and 64514. Maximum how many routers you can put in the one private ACE number in the configuration? Maximum you can put the 2 routers. Because if you're going to put the 3 routers, then what happens? Same split horizon rule comes in the picture, right? Loop prevention. Then again, you need to do the RR in under the configuration. So that's why you can put the maximum 2 routers. So what happened? Router 6 will share this information to router 1, this information 6.0.0. Router 1 can share this information to router 2, right? 6.0.0. Between the router 2 and router 3, if you see that, this is gonna run as a configuration IBGP, right? And this is gonna run as a configuration eBGP. So we don't have any issue in the eBGP, right? So R2 can exchange the router with the R3 as well. Now R3 can set this info to R4, and R4 can set this info to R5. And now R5 can set this info to R7. But understand the concept. When R5 is going to share this 6.0 information to R7, how they will do that? Within the ISPs, right? I'm going to put my ACE number itself, but I'm never going to share the private ACE number to the ISP. So when the ISP is going to share this information 6.0 to the R7, it will strip out all the private ACE number. They will only send the public ACE number 1, right? And they will put the ACE number 1 to 3 as well. They will never share this private ACE. So this company will never, Nokia company will never has an idea that this route is coming from the different private ACE. They will never have an idea what ISP did internally. Have they done the RR or have they done with the configuration as well? So these private ACE number never will be traveled to the different company. So it only pertains within the ISPs, never to the different companies. So this is how the configuration is. We are just going to break out the main large AES public AES into the private AES. You can, instead of the private in the practically, you can do the public AES as well, 2, 3, 4, something like that. But in the production, it's not like that, because for the public AES you have to pay the money. Okay, so it's simple like that. We have a daddy, right? We have a daddy, and for the daddy, we have a multiple son. So we have a son 1, son 2, and son 3. That's simple logic. Between the son, what happened, dado 2 and dado 3, right? Between the son, what happened, we need to make a relationship. That relationship is called as a peer relationship. Peer means what? It's a brother. Between this guy to this guy, what relationship will be there? It's a peer relationship. It's a brother. So we need to use this statement peer between. So I need to tell this guy, hey, 64512, you are my brother. And 64513 also will say that, hey, you are also my brother. And he will also say, hey, you are also my brother. So we are the son of same daddy, right? So this is how your configuration is going to work, guys. Configuration, it's very pretty simple. What you can do that. Let me check what IP addresses I have configured on this guy. In production, if I talk about all those things, you can see configuration, RR, and full mesh. Now, why configuration comes in the picture? So I'll tell you one thing. This configuration and RR, right? Both were see, full mesh was a problem, right? So in the 90s time, what happened? Two different engineers were working with the solution of the full mesh. So one engineer gave the solution of the RR, another engineer gave the solution of the configuration. Now, why configuration and RR are working in the production network like a same time, right? Because in multiple times you will see the RR because of the easy to configure. But configuration has an amazing benefit. Amazing benefit, I'm telling you. Personally, if you ask me, I like configuration because it has a great feature, right? You will not understand right now what I'm telling you. Configuration is amazing. What people are saying that, okay, configuration is a bad thing. Because the reason only that, because configuration has a lots of configuration. But apart from the features, if you see of the configuration, amazing. Because within the ISP, understand, within the same AS number, what they are allowing you the eBGP. We have a eBGP between this guy to this guy, configuration eBGP. It's not a pure eBGP. It's a configuration eBGP. Okay, so that's a beauty part of this guy. So let me check now. Why this router is not popping up? Okay, I think so. Let me check. Meantime, I have a config. Swiping is brief. Swiping EAGRP is there. So why the EAGRP is there? Just because of the next hop utility, nothing else. I'll remove the EAGRP. I'll do the starting point. So I just want IP addresses over there. So the router 1, router 6, what I can do that? Router BGP number 1. I'll say that router AS number 1. Right? This is router 6 we have. BGP router ID, I can call this guy the 6.6.6.6.6. Neighborship 10. What I okay 192.60.16.1. So router 6 is gonna form the neighborship with the router number 1, right? What AS number I have to put? Of course, Cisco only know about the public AS number. They don't know about the private AS number. So we need to put the remote AS will be what? We need to put the remote AS will be 1, 2, 3. Perfect. Network I need to advertise 6.0.0.0.0. That's all. On router 1 now, what I can do that? Router BGP number 1. Do I need to put the 1? No. We need to go with the configuration. So I need to put the private AS number 64512. Now what I'm going to tell this guy, hey, I'm a son, but my daddy is home. My daddy is a 1, 2, 3. That's all. I said the neighbor now. 1. And I'm going to say the neighbor will be 23.3. Sorry. Oh, my bad. Okay. This should be go with the 16.6. This should be go with the 12.2. And this guy gonna use the remote ASLV what? It's a 64512. So can you see that? Router 1 and router 2 is gonna make a configuration IBGP. Then router 2 now, router BGP number 1, 64512, right? I'm a same daddy. Right? Then after that, configuration, right? Neighbor. All done. And router 2 also gonna form the neighborship with the 23.3, which is the R3, but this guy's gonna use the remote AS will be 64513. I need to also say that one more thing. What? If you are the neighbor, you are my brother too, right? By this guy is getting multiple routers. All done. That's for router number 2. Let's go with the router 3 now. Pretty simple configuration, man. You just need to have two things. That's all. 64513, same daddy, but my brother, you are my brother. So R3 also need to tell, hey, you are my brother. And this guy go with the 23.2, 64512. Same thing, this guy go with the 64513 on R3. I need to change this guy will be. Have a look at the configuration, guys. Pretty simple. It's all about the practice. If you have done the practice of the BGP, it will become very easy for you understanding right now. Only we have added the 2 extra configuration. Right? R4. 3. This guy will be same daddy. R4 will say the what? R4 is gonna have this guy. So brother is 64514. This guy go with the 34.3 now. And this guy go with the 45.5. That's gonna have the 64514. All done. Then data 5 we have finally. Data 5, if you see, I just have a single data. You can have a minimum 1 data, maximum 2 datas in a one configuration identifier. In a one configuration box, you will have a max to max 2 data, either minimum 1 data. You cannot go with the 3. If you're gonna go with the 3, then again loop prevention comes in the picture, split horizontal. Then under the configuration, then what happened? You have to do the data reflector or the full mesh. I'll make a video on this thing. Okay, like within the configuration data reflector behavior. I'll make a video on this thing. I'll upload on the YouTube as well. R7. On R7, if you see router BGP, that's a Nokia router 7. I said the BGP router ID will be what? It's I can call it 7.7.7. I said the neighbor will be 57.7. That's gonna use the remote ASLV one. So customer will only have idea of what they only know about the public case number and network. That's all. One thing that I missed over there, if you see, I also need to form the neighborship with the 57.7, which is the AS number 2. And I love to give the router ID manually when I'm used to of this thing. If you're planning for the CCL lab exam, guys, make a habit of this thing to configure router ID manually, always. If you're not going to configure, they will lose the max. You will lose, and then you'll say, hey, law, I match all the output. My ping was working fine. Tracer was working fine. But I got a, like, I feel. So there will be no percentage. You just get a mail from the Cisco. When you click the mail, right, you will see you feel. I'll show you the mail, how the mail is coming if I have in my laptop. Okay. That's great, right? So have a look. Let me close my multiple bin.
In router 5, how 3 neighbors?
I'm coming to the so just give me one. Let me close this thing first. Multiple names open. R1, R2, R3, R2, R5, R5, R6, R7. Let me remove this guy. Okay. R5 only have 2 neighbor. Did I put the 3 neighbor?
Yeah. Yeah, in your
I'm so sorry.
configuration.
Yeah, I'm so sorry. My bad. So let me do one thing. I'll go on the router one. I'll show you the IP configuration of router one first of all. So IP interface brief, you see that I have IP on the router one. On a router two as well. Show IP interface brief. I have a IP as well. 12.223.2. So IP interface brief. I have all those things. R4 now. All good. R7 as well. That's an okay router. Perfect. R5. R6. One thing, I'm going to remove the EHGRP right now. The reason I'm going to remove it, you will understand later. Okay. Because I just want to do everything from the scratch, right? That's why I'm going to remove it now. You will understand why do we need a routing EHGRP on R6 on R5. Okay, man, let's start. R6, we have router 6. Let's go on the router 6 and put this command. Here we go. Router 1. Router 2. Oh. Okay. Configuration. R3. R4. R5. Okay. It's only 45.4, right? R5 is going to form the neighborhood with the 45.4. R6. Did I make a mistake? Okay. It's always 64514. You understood, right? Where is the mistake is there? By mistake, I can feel it wrong. Again, same mistake. Wow. Let me check where I'm doing the mistake right now. Fine. Here we go, bingo. So now have a look on the router 1, man. So router 1, you can see that. Not router 1, router 6, you can see that we are forming the neighborhood. And if you see, do show BGP right now. I'm advertising my route. This route is a valid and best. The next hop 0.0.0 means what? It's a very important question in the interview. What is the meaning of next hop 0.0.0? So this is the meaning of next hop 0.0 means what? It's a locally originated route. It means that on the router 6 itself, I have advertised the route. Locally originated, right? R6 is going to advertise the route to the route 1. If you see route 1 will receive this route to show IP BGP and have this route, right? So R1 will receive this route as a next hop will be 16.6, and you have a AES path information 1 over there in the R1 BGP table. This is the best route, so I can install in my routing table too. So you can see that do show IP route BGP. I can install in my routing table too. R2 will have this information, do show IP BGP. But if you see, this route is not a best. Can anyone tell me what's the reason behind it? R1 has a best route right now, but R2 doesn't have. Anyone knows what's the reason behind it?
Because R1 is directly connected to, the R6.
R1 has a direct reachability with the next hop, 16.6, right?
Correct.
Okay, you can ping this guy. And I can reach it. How about the R2? Will R2 can ping this guy? No. Why? We don't have reachability, right?
Correct.
IBGP does not change the next hop by default. So when R1 is going to advance route to router number 2, it put the same next hop over there. So you need to go on the router number 1 and say that one thing. Hey, listen. Multiple solution is there. Best solution that I'm giving right now. You need to go on this guy, 64512, and say that neighbor 12 or 2. Hey, IBGP by default not changing the next hop. Please change the next hop. So I'm saying that whenever you're going to advertise the route to router number 2, please use this next hop, self next hop, 12.1 instead of the 16.1. Sorry, instead of 16.6, use the 12.1. All done now. Do clear IP BGP stick, stop. You need to receive the BGP always. Great. And now if you go in the router 2, and here we go. My next hop had changed. Previously it was 16.6. It's now 12.1. And from the 12.1, I have a utility. So I make this route as the best route. Previously it was not. Now again, the problem is what? R2 has a route. How the R3 now? Does R3 have a route? Do show IBGP? I have, but next hop is 12.1. So what I can do that? Better to run the EGRP now. So normally the next hop self command is going to work when you're getting the route from the eBGP to IBGP. Then you can use the next hop. eBGP to IBGP. Then you can use the next hop self, right? But when I have a IBGP to IBGP, how can I use the next hop? If you see, originally this is the IBGP, right? I use the configuration to change the behavior, but originally it's IBGP. So I cannot use the next hop self over there. So better to run the EGRP now or a static route.
R1 or R2?
On every router you need to run, right? Because R4 also have the same behavior. R5 also have the same behavior, right?
Okay.
Yeah, go ahead.
Can I ask something? Okay, what I was saying that if you are configuring two different protocols like EIGRP
I'm
and
just
BGP,
using the
can you?
EIGRP just to make a next hop reachability. One thing understand, right now, that's an NP label. You have a confusion. I know if not you, every single person has a confusion. Why? If you already have a BGP, then why need of EIGRP again? We understand one thing. IGP is a routing, sorry, EIGRP, BGP is the routing protocol that is used
That's
to
right, yeah.
exchange the customer route. Now, in a BGP protocol, what happened? We have a next hop. If your next hop is not reachable, right? If the next hop is not reachable, then BGP never marks this route as a best route. Okay. So I need to provide the
Right.
reachability from R3 to the next hop. How do I do that? I need to run the
Within the
EIGRP
network.
routing protocol, any OSPF or any static route. Maybe you have a question, hey, Law, why we are not going to advertise this route in the BGP protocol? There will be security concern. How? Understand. Little thoda sa high hoga, thoda sa little bit high. Understand.
No, that's okay.
If
That's fine.
I'm going to advertise this guy in the BGP protocol, then what happened? This guy, They can understand. If I'm going to advertise this route in the BGP 12.0, 23.0, 34.0, and 45.0, I need to advertise all this route in the BGP. So if I'm going to advertise all this route in the BGP, then what happened? Finally, R5 is going to advertise this route to the R7, all this route. R7 is a Nokia customer. Now this router 7, the customer has a complete knowledge about your ISP's network. They can make attack in your network.
You don't do redistribution here, right? When you're using the different protocols.
No need to do that. So that's why it's never recommendation to advertise this link in the BGP. Always remember one thing. It's a big security concern. Okay, that's why I'm telling you, hold on. You will see multiple things, man. When you go in the higher level now, multiple things comes in the picture. Okay,
Right.
let's
But that only happens when it's IBGP, right? Inside the
yeah, IBGP has a because IBGP does not change the next hop. Only the issue with the IBGP, not the EBGP. EBGP does change the next hop.
no worries. Thanks.
Okay, R4. Guys, everyone understand, right? Bujar, you got it?
Yes, sir. Yes.
Great, great, great. Saurabh, you understood, right?
Yes, sir.
45.
Yeah, that's fine, no problem. That's fine. Thank you.
R5 now routing AGRP. IGP is only helping the BGP. That's all.
Okay, nothing else.
Nothing else. On a router 1. We are 2 now. Right? I form the neighborship R3 as well. So now R3, if you see the do show IP BGP, if you see that this route is not a best right now, do show IP BGP, if you see that it's showing that inaccessible right now. Let's see that. Do show IP BGP 6.0.0. The next hop is inaccessible. I cannot reach this guy. Accessible means what? I can reach. Inaccessible means I cannot reach. So I cannot install this route in my what? BGP routing table. Do so IP route BGP. I don't have anything. Because this route is just a valid route, not the best. To make a best, make a reachability. R4, R5. Now previously R3 was not a best route. It was inaccessible, right? With the same command now. This route is best now because my next hop is reachable. I can ping this guy next hop. Right? And do show IPGP 6.0.0. This is the best now. Same thing now, R4 also best. And I can install in my routing table as well. If the route is best. Because from R4, I can reach to the 12.1, right? Through the EHRP routing table. How can I reach the 12.1? If you look to the routing table of the 12.1, it will reference you to the EHRP. That's how the troubleshoot is working in the production. R5, do show IBGP. I have. Awesome, right? So you can see that all my configuration AS number is a part of the what? In the bracket. Public AS number is over here, 1. That's this guy, R6. And now R7, if you go, what happened? When R5 is going to advertise the route to the R7, it will remove the private AS number. This guy doesn't have a neighbor with R5. Why? Hold on. R7, R5 has no neighborship. Why? I have a configuration. It's in the ideal. Why? Why you're in the ideal? I can just mistake, man. Manual configuration always give a mistake. It should be the 192, not the 129. Right. But again, issue is coming right appear in the wrong ace. Why? Move on.
In router 7, you mentioned router BGP 7 is it should be
Oh,
2, right?
yeah, it should be 2, man. All right. Wait for some time and you will see the name. Yep. So now you can see the do show IP BGP. I have this guy. So you have a publication, but not the private. So private ace number till you will see till over here, not the on the customer side. It will never advertise. That's a private configuration ace number. So if you see on the route of 5 right now, you will see the all the private ace in the BGP table. And if it's the do show IP BGP right now, 6.0.0, R5 will say that, hey, you know one thing, I'm receiving this route from the configuration external neighbor. Yeah. Because R5 and R4, we have two different AES numbers, 64514 and 64513. Configuration EBGP, external node. But if you check the same command on the route 4, what you will see that configuration internal. All good? Because R3 and R4, we have internal navigation. So that's how you can do the configuration. So now R7 has it out. But how about this guy now? R7 has a 7.0.0 from this side as well. R7 is going to advertise this route to the R5. Okay, R5 will receive this route as a 57.7. By default, IBGP does not change the next hop. So when R5 is going to advertise this route to the R4, will it change the next hop? No, they will not change. R4 will still have a what? 57.7 as a next hop. So this route is again not a best because my reachability is not there. What a command I'm gonna use on R5 as well. On R5, I'll just go and say that, hey, whenever you're gonna send the update to the this guy, please use the next hop behavior. All done now. Do clear BGP strict soft and it will send the route refresh message and now R4 will have a reachability. So now when the R5 is gonna advertise the route to the R4, it will add the own next hop IP address instead of this guy. So now you can see on the R2 as well, you will see the do show IP BGP 7.0 is coming. Configuration eyes. If you remember that I told you this I is going to represent that the route we are getting from the IBGP, right? You will not see the route over there. It's a EBGP route. Now on the R6 and R7 between the Cisco Bangalore to the Cisco Nokia, I do have a good communication. If I'm going to ping, all good. Look back number 1. So I'm using the source IP will be 7.77. Destination will be 6.6.6. So this is the packet look like, right? Source and destination. That's how I use the source as a look back. All good, guys?
Yeah, that's fine. Good.
So I'll see this notepad. I'll change this command line on the R5 as well. Okay, apart from the next step, we have multiple things. Okay, you will understand in the CCI part because now you will not understand over here right now. So leave it this part.
So next hop self is just like in simple terms,
Changing
select
the
next hop. That's it.
changing the next hop behavior.
Changing the next hop behavior.
Right, that's all. Because IBGP does not change the next hop, right?
So self means what? Next hop is
the
next hop. That
self means what? I'm gonna put my own IP address instead of this guy. Normally, what happened when R7 is gonna advertise this route to the R5? What will be the next hop? 7.0.0.0, and the next hop will be 57.7, right? So in the R5 BGP table, what
Exactly.
happened? You will see the 7.0.0.0 as a 57.7 as the next hop. But when R5 is gonna advertise this route to the R4, by default, IBGP does not change the next hop. So we'll say the 7.0.0.0 as a 57.7, right? So can I ping the 57.7 from here to here? No, you cannot. So I need to say that, hey, please next hop self. Self means what? Use this IP address because I'm forming the neighborship between this guy to this guy. Use this IP address as a next hop when I'm going to send the update to the R4. So now this will be changed from the 45.5. And now 45.5 is reachable from the R4, right? Because it's the same broadcast.
Well, I remember that in static routing, right? Although it's a little bit irrelevant question. Static routing we used to under the next hop when we do the routing from one end to
Oh,
another
that's a
end.
different thing. That's a different. Don't compare with this thing.
Okay,
Yeah, don't
so
compare.
it's
Yeah.
totally
Next
different
hop is
behavior
always
here.
the neighbor IP address, right?
That's right. Yeah, in
Yeah.
common terms, yes.
Yeah. That's not this different.
Okay,
Okay, all good.
that's fine.
Okay, so now what I can see, what I have, let's go with the one more topic of the BGP. That's interesting one because you will encounter in the interviews and the production. Most every production running this features. GPA.
Right.
So what PA group is gonna do that? I'll explain. Hold on. You will already not already. You will understand this thing in just a configuration way. So let me up this device. And you can see that right now.
इसका कलर चेंज कर दें पीछे से.
Yeah, that's I'm thinking right now because it's little bit dark.
Exactly. That's better. Thank you.
So what I'm telling you, what I'm gonna do that right now. So all these are my client router. All these my client router. These are my client router. This is client router. This is my server router.
Right.
I'm gonna do the router effect, of course, right? So I need to use this configuration. So R1 is gonna form the neighborship with the 5.5.5. That's loop back. R4 is gonna form the neighborship with the loop back. All the client, that's a behavior of RR, right? All the client is gonna make the neighbor relationship with the RR, or we can say that all the client is gonna make the neighbor relationship with the server only, right? How you will do that? The first and most important thing, BGP always needs a utility. So I need to advertise this loop back into the which protocol, EAGRP, or maybe the OSPF, or maybe the static route. So if the utility will be there, then the BGP comes in the picture, right? So let's do the configuration of the EIGRP right now.
Sure. So basically, IBGP protocols we only use the only purpose for using is just for the reachability. That's it. Once the
IGP,
reachability
yeah,
is done,
IGP protocol, right? Perfect one.
yeah,
Only for the next stop utility. That's
IGP,
all.
sorry.
You could
Once
also
that part is
advertise.
done,
You could also advertise those route in the BGP protocol, but security comes in the picture, right? Security concern will be there.
what do you mean by other protocols like OSPF and
No, you can
resolution?
also instead of running the EIGRP or OSPF or maybe the static route or maybe the ISS, you can also advertise
Okay.
BGP, right?
Okay, BGP, I see.
But
Okay,
the security will be there, right? Concerned.
sure. Once the connection established, then the next then the BGP will take over the next.
Right, right. So once we done this part, because always we need utility, then we'll do the BGP. 25.0. So my agenda is what? Here we are gonna form the neighborship with the loop back to loop back. Hold on, it's a very simple topic. We are going to be very, very simple, but very important. R4 now. And I'm simply gonna
Okay,
call
got
all
it.
the routes because R4 has a multiple networks. So I simply call it. So let's do that.
Then what is 11 network at the top of R1?
So that's I'm assuming that customer network.
Okay. Okay.
That's I'm not gonna advertise in the EAJ because these are the customer, right? So I'm gonna assume advertise in the BGP protocol so that every router can have this network 11.0. So we are getting this route from the one of the customer to the ISP. Then ISP is gonna send this information to all the client. So this is the client router. Also client. Also client. Also client. And this is the server. So we are making a new relationship between the loop back to loop back. Indirect neighborship, not the direct neighborship. Let's check what configuration I do have right now. Maybe the EHRP will be there. I think so. Yeah, looks like EHRP is there. So let me show you the router 1 configuration, right? So IP interface brief. Guys, you can take a sniff right now because I don't have a space to put in this everything in a single place. Or either I can do one thing, I can reduce the zoom out a little bit, then you can see everything in a single picture. Perfect, right? Perfect, right? So you can see on the router 1, we have a 15.1 and loop back. So IP protocol summary, let me check what we have. Okay, I have a EHRP. Let me show you EHRP, what EHRP I did. Perfect, same network that I did in the notepad as well. R2. Same thing that I did in the paint, sorry, notepad as well. Perfect, right? R3 as well. Done. R5 last. So it means that we have a utility, man. R5 must know about all this loopback network. So IP root EHRP. Perfect, I do have. So it means that I can form the IBGP neighborship. So what I can do that on the router 1. Router 1 is a client router. So router BGP number 1, 2, 3, 4. That's my AS number. Right? The BGP router ID 111. Neighborship I'm gonna form with the loopback R5. That's my server. So when I want to form the neighborship with the loopback, then I need to change the source as well because by default source will be exit interface. I need to say that hey, change the source with the loopback 1. L1 means loopback number 1. Okay. Now what? Anything else? IBGP already have a 255 TTL. You don't need to do that. Let's do the password as well. Authentication part. So I'll say the password will be CCI. All done, right? Exit. Same configuration, this client configuration will be the, or I need to also advertise my route as well. So I have a customer route. Do I have this look back on the router one? I don't have it. Let me create it. So on router one is done. How about the router two, no, guys? Router two, we just need to copy and paste it because all the client have a same configuration, right? All the client is gonna form the neighborship with the same router. Only need to change the router ID. All the client router have same one. Only need to change the router ID. Now what? How about the router 5 now, guys? So I'm gonna show you the two notepad for the router 5. You tell me which one is the better. Automatically, you will understand why do we need a peer group. Okay. Why do we need a BGP peer group? Okay. So I'll say the router 5, router BGP. Okay, 1, 2, 3, 4, 5. BGP router ID will be 5050505. And I say the neighbor. Okay, let me show you this thing in the different notepad first of all. Now on the router 5, router BGP number 1, 2, 3, 4, 5. BGP router ID will be okay. Neighborship. I'm gonna make the 10101. All the server router is gonna make a neighbor list with all the client router. Remote is 1, 2, 3, 4, 5. Then after I need to say that, hey, you are a client as well. Route reflect a client. Then password. That's a very important CCI. Same configuration I need to apply for the what? Same configuration I need to apply for what?
I don't get this 1, 2, 3, 4, 5.
What do you mean? That's I'm coming to the point. Well, just give me 1 minute more. I'm almost,
problem.
you are almost done. You're almost there, right? Just give me 1 minute. I'm coming to the same point.
No worries.
You catch the correct thing. I just want to explain same thing. So this is the 4 now. Copy and paste. See how many lines of configuration you have, guys? 4 lines. 8, 16
Yeah.
total. 16 lines of configuration I have just for the 4 neighbor. Assume if you have 100 routers, how many lines of configuration you will have? 400 lines of configuration. Can you imagine you're running config of your router? If you just put the space, you will be end up the BGP configuration after the 10 to 20 minutes after putting the space in a space. 400 lines of enough configuration only for the neighborship. Right, router doesn't mean that only the BGP, right? Router can do the another thing as well, like OSPF, NTP, and what we call NATPAT, MPLS, multicast QS. And only the 400 lines of configuration is the BGP is gonna store how much amount of memory and CPU will take. Troubleshoot will become very hectic, man. What are the common things about this thing? If you this command line, if you see that common thing,
CCI.
All these are common, right? Same remote AES, same update source, same router, same this guy. All these things are common. Can I do like this way? What are the common things I have? I'll make a box of this thing, right? And in this particular box, I will put all this common thing. Right? Let's create the box over there. How do we create the box? I said the neighbor. Right? I will define any name for this guy as the, let's do that. What? CCI, not the CCNP, peer group. So the peer group, I have a name. So peer group is what? It's like a box. And in this box, I have defined the name of this guy, says a CCN. And under this box, I'm going to call what? Under this box, I'm going to call the remote AES update source. CCN. I have called everything in the single box right now. The remote AES update source, go back number 1, and then password, CCI, and RR. And now I'm going to apply this box to the each neighbor. I'm going to say that neighbor. Fetch the information from the CCNP group. And whatever the information in the CCNP group, we have a remote AES passport client and update source. I just need to apply these boxes to the particular neighbor. So imagine if you have 100+ neighbor, you will save lots of the time, lots of the troubleshooting. So if you compare these bulky configuration, right? This bulky configuration, if you compare this bulky configuration with this guy, it's a very minimal. How much command? We have a total of how many lines we have? 16 this line to this line, right? Total 18 lines of configuration I have. How much we have? 1, 2, 3, 4, 5, 6, 7, and 4, 11. Difference in just for the 4 neighbors. Can you imagine how much neighbor you have? Now take example. If you're getting the another router, right? Maybe the router 6 and 7. You just need to call the router 6. Yeah, listen, 6. I'm gonna put the configuration from here.
You just keep adding it. That's it.
Just keep
If you,
adding.
if you want to
Nothing.
add.
We have already created this template. Template means what? A dhacha,
Yeah.
right? We have already created this template.
Yeah.
I just need to apply this template to this guy. But this template is called as a CLI based template. In SD-WAN, you will see as a GUI based template. That's a SD-WAN is all about what? Template based configuration.
Right.
So now, instead of doing this notepad, I'm gonna do this notepad. I'm gonna do this notepad instead of that one. So let's do the configuration that of all the client right now. Start with the other one. That's a benefit of the peer group. Peer group saves the configuration. Save the
Right.
configuration, improve the data performance, save the lots of CPU, lots of memory, everything they're doing, making the network very
Time
easy
as
to
well.
see. Troubleshoot will be easy because you don't have a bulky configuration on your router side. If you don't use the peer group, then you have bulky configuration on the router side. And if you have bulky configuration, it's very become too hard to troubleshoot the network. And every time, whenever the new router comes in the picture, you need to put the configuration for the new router. With the help of peer group, what happened? Already template is there. I just need to apply the template.
So basically, the root reflect is very, very important in BGP,
Right, in IBGP.
in IBGP, sorry.
Stick.
Because I was gonna ask you this question because yesterday you created the
Yeah,
three
man.
routers,
We
client,
able to-
server, and yeah. So I
Uh,
was wondering if there are more than three routers, then how will you configure it out?
so there's a free 5 router now.
Yeah. No, that's understandable. You can add more lines. That's it.
Yeah,
Four
yeah.
routers. That's it.
It's all about the design, man.
It's all about the design. Just add
Uh,
more router into the
Right.
with the central router. That's it. Yeah.
So my neighbor is came up. You can see the show IPVGP summary. I do have all neighborship.
Right.
And you can see the show IPVGP peer group as well. I have this peer group. This is the internal peer group right now. And now you can see that R1 is extending the route with the R5 and R5 can reflect this out to the all the router. So R2 can see that do show IPVGP. Can anyone tell me what will be the next hop if I'm going to look for the 11.0.0.0 on the router 2? What will be the next hop?
11.0.0. That is the IP of the router 1, right?
Right. I have advertised this route on the
So-
router 1. You can see that.
Yeah.
It will send this information to the RR. That's the server. Server can reflect the
Mhm.
information to all the client, right?
That's right. Yeah.
So this client on R2, what will be the next hop for the 11.0?
Mm,
If you answer this question, I'm telling you, it means that you understanding the BGP now. And the major part I'm telling you of the BGP troubleshoot, next hop part. The most
So
important.
from router 1 to router 2, you want to know the next hop. The next hop will be the 25 dot.
Why 25.5? IBGP does not change the next hop.
So
It's
15 dot
why 15.5?
next
No 15.5 because I'm forming the neighborship with the loop back to loop back. It should be the 1.1.1. You are forming the neighborship with loop back to loop back, not the physical, right?
I see what you mean. Okay. So this the interface of the F0.0/0 of the router 2. That is the
No. When R5 is gonna send this information, right?
Mhm.
R5 is gonna send this information. 1 minute.
Uh-huh.
Not R5. When R1 is gonna send the R1 is forming the neighborship with the loop back to loop back, right?
Correct. Yeah.
Right. So when R1
With
is
every with every
11.0.0, he will put the next of as the loop back number, right? 1.1. We are not forming the neighborship with the physical interface. If you are forming the neighborship with the physical interface, then the physical interface will become the next stop. But right now we are forming the neighborship with the loop back to loop back. So loop back will be the next stop. That's why I said don't compare this next stop with your static route. It's different. In BGP,
so
next
but the
stop,
loopback
yeah, go ahead.
but the loopback is 1.1.1 of the router 1, right?
Right.
Again, so isn't it?
Yeah, it's a correct.
Yeah, excuse me. So 11.0.0.0 that is just a network we are advertising.
Right. I'm assuming this is the customer network we are getting from the another customer.
Okay, but that is fine. We are assuming that is a customer network, but where is that? But you are only advertising into this router 1. That's it. Are you advertising
Why
to
should
the
I
others
advertise
as
on the
well?
all the I'm just advertising the router number. Router 1 will say this in for the RR, right? RR, what is the behavior of the router reflector? It will reflect the route to the all the client. Why am I going to advertise the route?
Automatically.
If I already advertised
Yes.
on the router 1, why do we need to advertise the route on the all the router?
Yeah, it will be done automatically when we
So that's a
advertise the
dynamic routing
networks.
protocol, not the static. In the
Yeah,
static, you need to do everywhere, right? Not in the dynamic
correct.
routing.
Yeah. So the question is still there. What is the next hop, right?
I I wrote that 1.1.1 is the next stop.
Okay, itself.
Yeah.
And that behavior is in loopback, right?
Yeah, because we are forming the neighborship with the loop back, not the physical.
Yeah, you told that yesterday, I believe. I think you told that yesterday. Okay. And the same behavior is for other routers.
Yeah.
For router 2,
Router
2.2
3 as
is,
well. Router 3 as well, the same look back.
yeah, I'm sure you told that yesterday as well. I think so. I'm sure
Watch
you
the
told
video,
that.
revise the classes, revise the videos.
No, I revised that. I just forgot. I'm fasting.
No issue,
Revised that.
understandable, understood. Not a big deal. BGP is a little tricky protocol. Most of the people, right? I'm telling you. I'm pausing the recording. I hope nobody has a question, right? In the peer group, guys. Now, Firoz, Huawei is a Kharaj, right? Nisar, Saurabh, Suraj, right? All you good guys with the peer group?
Yes, sir. Yes, sir.
Okay, let me share this guy. It's been
So
one.
tricky bus is one of the demanding protocol in the
Yeah,
industry.
it's always.
Yes, sir.
I've worked in different projects wherever went, I've seen this BGP. Everywhere is BGP. Everywhere is BGP. Obviously, I don't know the BGP, but I've seen it. And people got the configuration and troubleshooting.